How many kids will it take to lift a ton of water?
Experimental.
And how much slack is there in our bungee cord?
Experimental.
Welcome to Experimental, the knockout competition to find the country's sharpest science sharks. There are two teams intellectually beating their brains out this week. In the red, from Nether Green School in Sheffield, we have
Jonathan,
Jack, Inga,
and in green, from Oswald Road School in Manchester, we have
Jess, Erin, Nathan.
Those are the teams! Now, you don't have to be a rocket scientist to understand the rules. We'll show both teams the beginning of an experiment. Then, using smarts, sense, and science, they have to predict the experiment's outcome. Now, they will have the appropriate experimental equipment and the help, the knowledge of our science analysis matrix. Sam, any thoughts, Sam?
Only two things are certain, the universe and human stupidity, Otis, and I'm not certain about the universe.
It's a good job I'm not human, then. Hey, wait a minute. Anyway, on with the first experiment. Outside this here research lab is our testing ground, and it's there that we join Chief Experimenter Holly Willoughby.
Welcome to the experimental testing ground. Now this is rocket science. What we have here are three sets of rockets. A single rocket, two rockets strapped together, and two rockets strapped one behind the other. All the rockets are identical and contain equal amounts of gunpowder. Your challenge is to work out which pair of rockets will go the furthest and exactly how far will they go. Now to give you a clue, Herbie's going to set the single rocket off now. Rocket went 11.1 metres, so that's back to you.
Okay, guys, that is your challenge, and your experimental time starts now. For safety reasons, the teams cannot fire rockets in the lab, but they can get similar results by releasing balloons along strings. Okay, Jonathan, how far did the first balloon go?
2 metres, 31 centimetres.
Lovely. Okay, I'm about to release the twin set of balloons now. Here we go. Wow. Okay, Nathan, how far did that go?
3 metres, 26 centimetres.
Releasing the tandem balloons. And the booster rocket in 3, 2, 1. Okay, Inga, how far did that go?
3 metres, 30 centimetres.
Okay, so finally. Stuck together. Sam, what is it they need to do here? Because, I mean, a balloon is not a rocket, right?
One rocket carries its own weight. Two rockets together, twice the power, but twice the weight. Tandem rockets, they lose weight as the first rocket falls away.
Okay, teams, your time is up. Team captains, your predictions, please.
The tandem rocket, 15.857 metres. Tandem rocket, 15.87 metres.
Okay, then, let's see how their answers tie into reality. Holly.
Right, Otis, the area is now secured, and for safety reasons, the rockets will be fired electrically. And in charge of ignition is our resident technician, Herbie. Oh, Herbie, not now. It's time to start the countdown on the rockets that are strapped together. So, in 5, 4, 3, 2, 1. Right, Herbie, fire the next pair of rockets. Right, what was really interesting about that experiment was that the rockets that were strapped one on top of the other went virtually the same distance as the single rocket. And yet the rockets that were strapped one behind the other went further. In fact, they went a massive 12.4 metres.
Right now, percentage accuracy equals points. After the first round, our green team was 72% accurate, but the Reds was 73% accurate! Now, one child can easily lift 1 bucket of water, but the challenge facing our teams today is to try and calculate out how many members of our observation team it will take to lift 1 ton of water. That's the same weight as a baby elephant or a small car. Teams, your test time starts now. The teams are starting by determining how much one person can lift with the help of buckets on a pole. Now, Sam, I know that 1 litre of water weighs 1 kilogram, but where do you go from there?
The teams can measure how much one person can lift, but will it accurately reflect how much a group of people can lift, especially if they are using their legs rather than their arms?
You're strong.
Average person can lift, is it 2 easily, is it 4 easily, is it 3, is it in between the...
2, maybe, or 2.5. We can't have half a person.
There's some people who are weak. 2 times 10 is 20. And 20 times 1,000 divided by 20. But some people might be able to carry more.
All right, teams, time is up. Captains, your predictions, please.
40 people. 48 people.
OK, let's see how their theory ties in with reality. We have our observation team here ready to attempt to lift 1 ton. We have 24 in place at the moment. OK, guys, ready? Lift. And down. OK, that was a failed attempt. We're going to add another 8. We now have 32 members in place. OK, guys, are you ready? Lift. Ooh, not quite there. We're going to add another 8, taking it from 32 to 40. Remember, guys, you're all lifting from the knees, keeping your back straight. Are you ready? Lift. Oh, we're still having a problem picking it right up. Let's add another 8. Everybody shuffle forward. 3, 2, 1, lift. And down. OK, that's the result. It took 48 members of our observation team to lift 1 ton of water. The red team were 83% accurate, giving them a total of 156 points, but the greens were 100% accurate, giving them a leading score of 172. So, with the green team currently in the lead, let's join Holly for our next stunt.
Herbie, always keen to demonstrate his athletic skill, is going to help us with our next experiment. Oh, Herbie, I told you to switch off that invisible force field. Now we're going to need another stuntman. Welcome, Joss. Joss? Not only has Joss got to fight against air resistance, but he also has to fight against his own physical limitations, of which I can assure you there are none. He also has a bungee cord attached to his back. So, the challenge facing our teams is to work out how far Joss will get before he is whipped away.
OK, teams, that's your challenge. How far can Josh run before the bungee cord pulls him back? Your test time starts now. To test the elasticity of rubber, the teams have set up improvised stretching experiments using rubber bands and spring balances. Quite frankly, I'm confused. What's the setup here?
The stretchiness of the cord affects how much force is exerted in the opposite direction to the pull. Joss's bungee cord is twice as stretchy as the team's elastic bands.
So, Sam, ever considered a bungee jump?
Unlike you humans, like you, Otis, I am not stupid, and I would not want to burst my bubbles.
Look at it. meters. Yeah. course it's
Okay, time's up. Your predictions, please.
7.41 metres.
6.44 metres.
Okay, let's see how calculations tie in with reality. Holly.
Joss is in position, the bungee cords are connected, so ready, steady, go! Okay, Otis, Joss managed to get 8.4 metres. Now that's nearly as impressive as he is.
The Reds were 88% accurate in that round, giving them a grand total of 244 points. The Greens were 77% accurate, but it was just enough to give them the victory with 249 points. That means Green are today's winners, putting them in second place on our leaderboard. The top two teams on our leaderboard at the end of the series will battle it out in the grand final. But right now, the Green team has an opportunity to increase their score by predicting the outcome of the fourth and final stunt, the fabulous furniture fling-a-thon.
Our final game gives the winning team a chance to bump up their points a bit by simply guessing how far this nitrogen cannon can fling furniture. There's quite a selection out there, but as always, the choice goes to our observational team.
Right, observation team, which furniture gets flung next? Choose now.
Right, while Herbie loads the wardrobe onto the furniture flinger, I'd like to remind you of a third member of our team, our resident crash test dummy, Gerald. Now, Gerald suffered a bit of a nasty knock last week, but he does assure me that he's really looking forward to this week's furniture fling. Aren't you, Gerald?
So, guys, how far will the ram throw the wardrobe? You have 10 seconds, starting now. Our last fling was a toilet, which weighed slightly less and offered less air resistance than the wardrobe. That went 24.5 metres. Okay, guys, time's up. Let me know your guess.
20.5 metres.
An educated guess, but how close was it, Holly?
The wardrobe is now loaded, Gerald is in position, the whole area has been cleared for safety reasons. So, Herbie, let her rip!
Points. That puts them in second place, but will they still be there next time? Make sure you join us when another two teams will be taking a sideways glance at science with a blazing fuse and a barrel of gunpowder, a mini tornado right here in our studio, and Gerald, the crash test dummy, sinking like a stone. See you next time.